Hello and welcome everybody. Thank you very much for joining us. My name is Robin Cornish Hall. I'm the Digital Marketing and Events Manager for Chrysos Corporation and our technology PhotonAssay. I'm pleased to introduce Dr. Simon Dominy. Simon has 30 years of experience in mining operations as a company director, a technical advisor, consultant, competent or qualified person, and as an academic. This presentation is an overview of a recent paper that Simon published called PhotonAssay and International Code Compliance. So without further ado, I pass the microphone to Simon, and thank you again everyone for joining us.
Thanks very much, Robin, for the introduction. So the context of this this particular presentation is really across the fact that PhotonAssay is increasing international uptake, though a common question posed by potential users, both to Chrysos and indeed myself as well, is PhotonAssay NI 43101 and JORC compliant. I mean, the word compliant there for a start rings a few bells from those in the know. So I guess the short answer is yes, the real answer is no, but yes. And the true answer is it's not whether PhotonAssay itself is compliant, but whether the technology can be used in reports that are themselves written in accordance with the given code. And we'll as we progress. So the presentation focus, what we will be talking about is a high-level overview of key matters that the competent person, qualified person must consider for the public reporting of PhotonAssay results, specifically exploration results and/or mineral resources. It is not an in-depth review of the CRIRSCO codes. It is not an in-depth discussion of PhotonAssay. It's not an in-depth discussion of fire assay, PhotonAssay comparison protocols, and we're not going to have huge presentation on QAQC program setup analysis or metrics. Now, what we're going to cover is high-level market reporting within the CRIRSCO codes and what the key matters are, what needs to be disclosed when making a public report across what I call rig to assay, and then some summary and conclusions at the end. So it's all about gold, some pretty pictures of deposits I have worked on. Thankfully, not every gold deposit in the world has quite as much coarse visible gold as this, but many do. And PhotonAssay is one of the key tools that we now, as CPQPs, now have in our case to be able to use. So welcome to PhotonAssay. What is PhotonAssay? It's a method that delivers fast, safe, accurate and environmentally friendly gold assays, and it is a trusted alternative for fire assay across the industry. It works via shooting high energy X-rays to samples in a plastic jar, as you can see there on the bottom right. And then this goes effectively, there's an excitation and the sample passes into a measurement system. And based on that, within as little as 2 minutes, then a reading is taken of the gold assay of that particular sample. It matters because we can get a nice rapid turnaround, potentially 2 minutes, 70 samples an hour. And it hence provides, timely quantitative data that helps us to drive optimization through the value chain and hopefully deliver some operational and environmental outcomes that are useful to explorers and miners. So just very briefly, this is the sort of current standard Max unit, one of the units in Australia. If we go from right to left, we have the modulator cabin, which is the power for the LINAC. We then have the LINAC cabin, which is the linear accelerator that produces the X-ray source. And then we have the automation cabin where the sample effectively is handled and the measurement occurs. And then on the outside of the cabin, on the far left-hand side there, we have the feed into the machine, the operator console, and then the out feed once the samples have been assayed and come out of the unit. So the gross process is sample is loaded into a jar. It's generally crushed, but obviously in some cases we may need to pulverize, but crushed or pulverized material in a jar passes into the machine, gets zapped by X-rays, goes into the detectors where the 279 kilovolt gamma rays are detected and then calibrated against gold, and then there's an automatic reporting process. So the key features of PhotonAssay is time per sample, as little as 2 minutes, sample mass in an individual jar ranging between 400 and 650 grams, CO2 emission per jar approximately half that of a fire assay at about 0.45 kilos per jar. No hazardous waste, merely what is in the sample, jar. Energy usage again is about approximately half that of a fire assay at 0.65 kilowatt hours. And of course, it's a process that is highly automated. Once it's fed into the machine, it's fully automated until it comes out. So large samples are good, potential to be able to crush only, but we may need to pulverize on occasion. Non-destructive, no chemicals required. Non-destructive is really important because you can potentially use the sample again for something else. We've got detection limits down to about 0.01 gram per ton, assuming there's no interfering elements such as barium, uranium and thorium. And the whole measurement process is entirely independent of the matrix chemistry and mineralogy of the material in the jar. Can be used for various things across beyond the standard resource exploration, resource development, grade control. You know, we can use it for plant. We can put moist or dry samples in, samples with high sulfide minerals we can put in, which of course is problematic for fire assay. We can put carbon granule pulps from the plants. We can even put solutions in there from the plant. So, you know, it's a flexible method. There are 40 PhotonAssay units located around the world, and that covers approximately 70% of the world's top 20 gold producers, with about 600,000 jars being assayed every month across 4 continents, and clients such as Barrick, Agnico, Goldfields, Kinross, Northern Star, Evolution, etc. So just moving on now to the market reporting, and particularly talking about the CRIRSCO codes. The CRIRSCO template, this is the Committee for Mineral Resource and International Reporting Standards. The CRIRSCO template assists with the dissemination and promotion of good practices for public reporting of exploration results, mineral resources and oil mineral reserves. Each country or area has a national reporting organization which is responsible for the individual code. But each of the key codes around the world that we'll talk briefly about at the moment are templated to the international reporting template with CRIRSCO. Member countries including Australia, Brazil, Canada, Chile, Colombia, Europe, including the UK, India, Indonesia, Kazakhstan, Mongolia, the Philippines, South Africa, and Turkey, all helping to push towards this global alignment and compatibility. CRIRSCO includes the template, which is the table 1, section 3, subsections 3.4 to 3.6, where specifically here we're just looking at sample preparation, analysis, sampling governance, QAQC. So already within this template, you know, we're seeing the guidance of what we need to discuss, which of course is highly relevant from a PhotonAssay perspective if we're looking at reporting to the market. Key CRIRSCO codes will be obviously the JORC code 2012, currently under revision, the CIM definition standards for Canada, also currently under review, and the code that I'm linked with, the PERC reporting standard 2021, which is not currently under review. The principles of the codes are all pretty similar. They aim to protect investors from unsubstantiated or fraudulent claims by publicly listed companies. But they do and don't achieve this, but at the end of the day, they are a tool that we need to work with. They do not define what acceptable practices are. So they do not tell us as competent persons, qualified persons, what we have to do. The codes emphasize that the methods used and the resultant findings are reported truthfully, and that the competent qualified person has followed some level of industry best practice or has justified an alternative approach. Whilst the codes imply an overall sense of quality and consistency in reporting, none of them can actually prevent practitioners from either conducting poor technical work or from making misleading statements. when that occurs, then that is where the relevant exchanges and obviously professional organizations come in and deal with the matter. So the key code principles for all of them are transparency and materiality. Transparency requires the reader, the investor, the potential investor, or the advisor to be provided with sufficient information presented in a clear and unambiguous way. And materiality requires the reader to be presented with all relevant information so that the reader may make a reasoned judgment on what is reported. Where relevant disclosure is not made, an explanation must be provided for omission, and this is generally achieved through a checklist style tabulation, such as the JORC or PERC Table 1. And for instance, both PERC and JORC have the if not, why not approach. So if you don't report, if you're not putting relevant information in there, you have to explain why. I would always maintain that public reporting requires a strong degree of common sense. It really isn't hard. Another key principle of the codes is competency, which relates to the competent person or the qualified person, and that they've got relevant experience. Experience must align with the mineralization type and activity. If you've got 20 years experience in mineral sands, that's absolutely fine, but you're not really going to have the relevant experience to report, for instance, a high nugget, narrow vein tin, or potentially got gold style mineralization. Accountability, you need to take personal responsibility for the statements made in the public report. And professional standing, you need to be a member of a relevant self-disciplining group. In the UK, that might be the Geological Society of London. In Australia, that might be the AusIMM. And obviously in Canada, you've got the various professional groups across the various provinces. So if we start just to look at a little bit of detail, just first here at for instance, the JORC code, if we're looking here at Table 1, Section 1, subsampling techniques and sample preparation, quality of assay data and laboratory tests, verification of sampling and assay. This is where the competent person in the JORC sense needs to be considering what they're looking at and what they need to discuss in a relevant market report that, of course, would be highly relevant whether you're using PhotonAssay or whatever else. We also have NI 3 43101. Now, obviously, 43101 is a regulatory framework. It's law in Canada. It's not strictly a code, but it is intimately linked with the CIM standard. And if you're reporting in Canada, you clearly need to follow the what 43101 has to say. And here in section 3, subsection 2F, summary description of the type of analytical testing procedures utilized, sample size, the name and location of each analytical testing laboratory used, and any relationship of the laboratory users. So there's some guidelines there as to what we need to discuss. And obviously, if you're at a point where you're producing a 43101 report, you would refer to Form 43101F1, Section 11, sample preparation and analysis and security. And again, those are that's the guidance there for the level of disclosure that needs to be made by the qualified person for sampling and assaying. Assaying is PhotonAssay. So PhotonAssays can be widely applied across the mine value chain, right the way from the rig to the final concentrate, or the face to the final concentrate, whatever your sample type is. So exploration, resource development, grade control, ore control, metallurgical, geometallurgical test work, plant accounting, and concentrate. So the codes provide disclosure needs for all and any sample grades that are publicly reported wherever you are in the mine value chain. So if we come specifically to what the CPQP needs to think about across the rig to assay, we'll start in the field, we'll go to the laboratory, and then we'll go to the verification steps that the competent person, qualified person will need to do. So the next few slides, the dot points, the tick points here, they're not all inclusive. There's probably plenty of other things that can be added, but key considerations here at the field site. What method are you using? How are you collecting the samples from the RC rig or from the diamond core, or are you chip or channel sampling underground? How is material, how are the samples being recorded and bagged and boxed as appropriate? Logging, sample collection, core splitting, has that being done? What QC actions are you taking? Are you putting in your field duplicates? Are you doing your field blanks? What subsamples are you using? And ultimately, how are you splitting your RC sample? How are you splitting your core half versus whole core? Are you using half core or are you using whole core? Packaging, sample security and transport, what's the chain of custody? You need to have your QA documentation in process or in place with trained staff that are regularly reviewed. No point having QA documentation if you're not actually training your staff and reviewing them regularly to make sure that they're complying for the comfort of the CPQP. Once the sample arrives at the laboratory, we're now getting close to the PhotonAssay process. What are we using for particle size reduction? How are we crushing and pulverizing? What sample size reduction are we using? Are we using riffle or RSD splitting? Hopefully we're not spearing or grabbing or spooning. What QC actions are we taking? Is the equipment properly hygienic? Are we doing barren flushes? Are we doing our coarse crush duplicates? Are we putting in our blanks and our CRMs? And again, have we got the relevant QA documentation, trained staff and regular review in place? Then we come to the final stage, 100% relevant to PhotonAssay and the laboratory assay. Now, are we using an appropriate assay method? Are we doing our pulp or analytical duplicates? In the case of PhotonAssay, are we doing jar repeats? What other QC actions are we taking and making sure that we've got our CRMs and blanks in there? And that's for both the client and the laboratory. We should be submitting check samples to a different laboratory for PhotonAssay, and the CPQP may opt to submit check samples to the same or preferably a different laboratory, but for an alternative gold assay, for argument's sake, screen fire assay or a leach well with a fire assay of the tail, again, as part of the QC process. And again, even at this stage, QA documentation in place, staff trained and regularly reviewed. Very important is obviously the lab and its location and whether it's independent or certified. So, where is the lab? Is it on site or is it off site? Who operates the lab? Is it fully independent services group or operated by the mining company itself? Is it certified? Usual certification being ISO 17025, albeit obviously some countries do have their own local process. Key verification step by the CQP should always involve auditing the laboratory, as well as many other things, auditing the laboratory itself. Getting to visit the laboratory, looking at sample receipt and storage, pre and post assay, data management, the LIMS system, the organization of the lab itself. Is it clean and well organized? What's the potential for contamination? Are its internal QAQC systems adhering to agreed protocols? Is the analytical equipment looked after and calibrated appropriately? Is the lab in compliance with the accreditation that it says that it has? What's the quality and how are the crushers, pulverizers and splitters operated? And obviously, most importantly, health and safety. Is the lab operated in a professional and health and safety conscious way? I always like to stress this, but it's important for the competent person, qualified person, to be competent in auditing a laboratory. Just because somebody is a super world-class button presser and geostatistician from a block model perspective does not necessarily mean that they're actually competent to review and audit a laboratory. So it's always important to ensure that the person or persons that are auditing the laboratory are competent to do so. Audits should be regular. At the very least, once you start to work with a new laboratory, you need to audit it. Once you're starting a new drill program, you need to audit it. And I always like to audit labs, at the very least quarterly, and visit as and when if there's a problem to discuss. One verification step that the competent person, qualified person may wish to do, and this will probably be a lot earlier in the piece, is to do some sort of comparison between PhotonAssay and the existing assay method, which is probably almost certainly fire assay. So Chrysos has developed a couple of different protocols. This is what they call the traditional feasibility protocol, which effectively just compares fire assay with PhotonAssay. There's others that could be used as well. But this in making that journey of change from fire assay to PhotonAssay, this is an important part of initially, at least, of the verification step that the competent person, qualified person, may wish to follow. So, summary and conclusions. CRIRSCO-based reporting codes set out guidelines to listed entities as to how to publicly report exploration results, mineral resources, and ore/mineral reserves. No code defines acceptable practices, just that the methods used, approaches used, and the resultant findings are reported fully and truthfully. Transparency and materiality. The codes and associated documents, in this particular case, associated documents would be 43101 in collaboration with the CIM standard, outline how assay results should be reported to the market. They do not, however, outline which assay methods are reportable using said codes. It is not which assay method is or is not code compliant, but rather the way in which the method is disclosed via the code's requirements that makes the public report compliant, noting that we don't really use the word compliant, we use the phrase reported in accordance to. The application of PhotonAssay requires a decision by the relevant competent person, qualified person or persons, who must be satisfied that the method is appropriate and produces fit-for-purpose results as indicated by QC actions and verification as appropriate. There really are no barriers to the application of PhotonAssay in market releases, providing that the competent person, qualified person, has used their competency to disclose all material matters in a transparent manner. Okay, well, thank you. That's the end of the main part of the presentation. As Robin alluded to early on, we have actually we've not published, but we've released a draft paper. I've also put this on preprints.org, which means it's got a DOI, and this is part of a work that will be merged with 2 or 3 other papers that we're working on ultimately, and this is freely available either via Chrysos myself or via the DOI link there. We've published a number of other papers that are relevant to PhotonAssay. The early 2024, the application of PhotonAssay to coarse gold mineralization, the importance to assay optimization was a general discussion on the matter. Then a year or so later followed the evaluation of coarse gold conglomerate mineralization at Beaton's Creek, which is a case study of how all the sampling protocols developed with time at Beaton's and ultimately ended up using PhotonAssay, and with myself and Janice, co-author, signing off as QPs under 43101 on a resource there. And then most recently, a few months ago, we published a paper on geometallurgical sampling, but the case study actually involved the use of PhotonAssay, and the key part of PhotonAssay there was the fact that it doesn't destroy samples. So when you're very tight on samples that you want to use for metallurgical test work, you can assay them using PhotonAssay, then you can recombine the material and then do additional test work. The whole a really high value part of PhotonAssay to me is the fact that you can reuse the sample material. Okay, I think that brings us comfortably to the end, Robin.
All right, we have a question in the Q&A section from Ahmed. Thank you, Ahmed. What is the effect of spectral and matrix interferences in photon-based emission techniques such as PhotonAssay? And what strategies can be applied to minimize or overcome these interferences?
For PhotonAssay, we don't really have any interference with the matrix itself because, as Simon mentioned before, we do use really high energy X-rays, and what that does is it penetrates the whole sample. So if the sample itself is crushed or pulverized, we do measure all the gold within the sample. The only interference that interferes with the PhotonAssay measurement is the presence of uranium, thorium, or barium. And we do provide flags if if these elements are present. So the customer would know that we do have these sort of interference with the sample and measurement itself.
My two penneth with that one would be, certainly if I'm starting out on a new project where we're going to be looking at PhotonAssay, we actually like to do some uranium, thorium, barium assays right up front as part of to actually get an idea what's there, rather than just dive in. Actually do a bit of geochemistry first as part of the characterization process, just to just to give a heads up as to what we might expect. I'd rather expect it than have it as a surprise down the track.
We got a chat from Leo in the channel as well, saying what levels of barium become problematic. How does the technique monitor for this?
Yeah, so for barium, I think we only start seeing interference in the lower grade ranges when barium hits about 1 weight %. So for barium, we do really need more barium to actually interfere. For uranium, thorium, that is what we're more sensitive to. But barium is up to the weight % level.
Seuss has asked, thank you for the presentation. Big part of the bias in assay can be found in subsampling and preparation. Does the PhotonAssay system consider any additional sample preparation criteria or specifications? Perhaps, Joel, you could speak to that?
Yeah, thanks, Robin. Yeah, sample preparation, I think that definitely introduced majority of the error. I'm sure Simon can speak to that as well, especially when a sample comes from the rig. I think majority of the error does come from the splitting at the rig. By the time it gets to PhotonAssay, that the error is already, the majority of the error already comes down from the top. So we ourselves, Chrysos, we do perform what we call a heterogeneity study. And what that study does is it helps understand the sampling error at different size fractions. So we'll do studies and measurements at the crush size fraction, and then we'll redo that on the pulverized size fraction as well. And then what that gives us is the sampling error and coefficient of variance at crush versus pulverized, and then we can decide what's the best way to move forward from there. But Simon, I'm sure you have more comments on that as well.
Yeah, look, I mean, your heterogeneity study does that job. I've got things that I would do. I like to emphasize this whole rig to assay. Don't change anything there unless you look at the whole damn lot. If you're going to change from fire assay to PhotonAssay, fabulous. But look at the whole bloody thing from beginning to end. Don't just focus on changing one thing. You need to look at all. You need to look at all the levers. And it may well be, and I think with one of the questions we might have had this morning with Australia, I had this very point where we were looking at a coarse gold ore, and that split at the crushed size was just too erroneous, and our conclusion was actually we needed to pulverize. So you just do your homework. You do your characterization. You need to understand your mineralization. You need to understand your gold particle sizing. You need to understand how gold particle sizing relates to grade. And then you do your full on optimization. I should just make one clarification. Joel and I mean, I refer to it as well, talk about a heterogeneity study that Chrysos does, and that's part of their characterization to optimize what they do, but that is not a heterogeneity study a la PERC or Petard. So it's unfortunate that they've got the same names, but they're actually very different things. One is specific to Chrysos and moving to PhotonAssay. One is a more whole of all characterization program.
Yeah, perfect. Thank you, Simon. Oh, we've got lots of lively conversation coming in soon, so apologies if I call out of order here. We have a question from Joseph, switching a little bit to QAQC protocols. Are there any specific QAQC protocols or additional validation steps apart from the usual protocols recommended to ensure full compliance with these reporting codes? Simon, do you want to answer that question?
Yep, go do what you normally do. You don't need to do anything different. If it's up to your CPQP. If you put in all your standards and your blanks and your duplicates at 1 in 20, do it. There's nothing needs to change, but you need to do it. You need to analyze the data, and you need to act upon it. what drives me insane is people do these wonderful QAQC programs. They faff around and don't really analyze the data. Even if something comes up, they don't act upon it. And and I'm talking about client QAQC here. Now, Chrysos and PhotonAssay has its own QAQC system that I'm sure Joel will like to comment on now, which they run internally.
Yes, in terms of QAQC, we do have what we call monitoring standards inserted into the system. And then that standards, we are able to see live and basically monitor the unit monitors the performance of the unit by looking at these monitoring standards. So if any one of these CRM standards flags, sits outside of the 2 to 3 SD band, we will get a flag and then we'll look into that immediately.
Yeah, we have a global team of phys-ops, we call them. They're physicist operators, and they monitor live 24/7 as part of batch control and keep an eye on all of the batches that fail our certain measures. They troubleshoot with the client quite quickly on the user end, and it's a whole part of the service. A couple more questions which we've answered already regarding uranium, barium, and thorium. Asanda, we've mentioned that before. We'd be happy to send you some more materials if you like. Osvaldo, I'm not quite sure I understand. Great comments about the data. How do you integrate all the data silos? So, Joel, Gendrong, anything coming to mind? How might we answer that?
Yeah, I'm not sure. Sorry, Osvaldo, I'm not sure what you're referring to data silos, but for PhotonAssay, the report is shared via CSV file. So you run your samples as a batch, and then that batch gets reported as a CSV file to the LIMS system. But I'm not sure if that's what you're referring to there.
All right, thank you. A question from Alexander. QC difference in coarse, less than 2 millimeter sample, and QC being pulp. What variation would be expected with respect to concentration?
Difference in coarse.
Don't know. I'm not quite sure what that means. Are you talking about what would be the analytical precision if you take a jar of crushed and then zap it a few times and get see and try and work out the precision versus the same with the pulp? Depends on the ore type, I would say. If that's what you're referring to.
Possibly. Let's see. Coming back to uranium and thorium interferences, is that partly related to gamma emission? If yes, what about the other radioactive elements? Radon. Joel, can you see that question from Gilbert Stein?
Yes.
In the chat?
Yep, I can see that. Thanks, Gilbert. Yeah, so basically the way uranium, thorium, and barium interferes with the gold measurement is it increases the background reading. Increases the background reading. So when we activate the gold signal, what that does is the uranium, thorium, and barium is also activated slightly at the background level. So that really interferes with just the lower grade gold reading. So there's not much impact on grades above 0.3 ppm, but grades below 0.3 ppm gold, that is what's really affected. But above that, your uranium, thorium, and barium has very minimal impact on the gold measurement and precision itself.
Thanks, Joel. Question from Colby. How is the het tag generated during a standard 2-cycle analysis on a single sample?
Yeah, so the head flag is generated because, as you mentioned, we run a 2-cycle service. So each cycle, we have a top and bottom detector, and basically each detector with an individual reading. So over the 2 cycles, we have 4 individual measurements, and then we look at these 4 individual measurements. And if there's any big variation between the measurements itself, we will generate a head flag and basically inform you that is, yeah, the het basically means heterogeneous. When we say, you know, this material has potential of being heterogeneous due to the variation in the detector signals we get between the two cycles.
Thank you. Thank you. We've got some lively conversation going on now. Emma Molina is clarifying Alexander's earlier questions, referring to the CRMs being pulp materials and included in batches with samples that have only been crushed. Okay, so we've got potentially two different types of material going through in a batch. Is there any comment you want to make there, Joel or Ginzhuang?
I can comment on that. So I guess the question is around that for the QC, the CRMs we insert the standard materials, they are pulps because they are supplied from the suppliers, while the materials we measure their crust. So the answer to this is it doesn't matter. So as Joel and Professor Dominy just mentioned, the PhotonAssay technology is agnostic to particle size. So it measures the gold atoms in the materials. It doesn't care about the forms of the materials. But one thing that is nice to mention is for the current CRM suppliers, such as Aureus and CDN, they do have CRMs specifically for PhotonAssay. I don't know, Joe, if you want to add up to that.
No, yeah, thanks, Ginzhuang. I see the question now. Yeah, so thanks, yeah, so it doesn't really matter if the sample is crushed or pulp. We are able to tell you the gold amount within that jar itself because of the high energy X-rays. But yes, Ginzhuang mentioned that Aureus CDN does have PhotonAssay certified grades. So the way they do it is basically the same as they do fire assay. They send the samples over multiple units around the world for round robin, and then we obtain the certified grades in that way. So
a comment and a question in here from Joseph Becker. At NGM, we've been learning that we need to introduce new QAQC protocols in a post-fire assay era. An example is fill factor to weight issues, such as 300-gram weight and 97% fill factor are a flag for us. Are there any other QAQC new protocols that have been implemented across the industry that we should be paying attention to? Thank you for the question.
Yeah, sure. The fill factor is one, and certainly back in Novo days, going back 4 or 5 years when we were, I guess, some of the early adopters riding the wave here. It would be fair to say that the fill factor is one that we didn't focus on too much to our detriment at one point, but ultimately we sorted that out with the database and some filters to flag. But other than that, no, nothing wildly comes to matter because you're still doing your field, your course, your analytical duplicates. You're putting in your CRMs, whether they be the pulverized or the crushed ones. I must admit, I've only had experience of using the pulverized ones. I'm obviously more than aware of the crushed ones, but not used them to date. No, not that I can think of.
And another question, how might one obtain lab audit competency? I've done a few. Does that make me competent? Thank you for the question.
Yes. Well, I guess that's the big question of which somebody's written a book on all this kind of stuff. Look, it's like how the hell do you become competent to be a competent person? It's the $1 million question. Certainly, all I can do is talk in my case, and that is, in my formative years, I was lucky enough to go around various laboratories with people that knew about laboratories. I got to work in some laboratories, albeit they were university laboratories. I would say if you want to be competent at auditing a lab, but buddy up with a colleague, a friend, mentor, and go off and do some lab audits and learn about labs and go and visit labs. The vast majority of the commercial labs are pretty friendly people, and if you contact them and say, I'd like to come have a look around, please, and show me what you do and how you do it, most of them have an open door principle, and so I think it's you gain lab competency just as the way you gain competency as a competent person. You do the job, you talk to people, you get yourself some good mentors.
Thanks for the question. We have another question from Michael Dunning. Tim Sennett, I might ask you to take this one. If you unmute yourself, you can speak in a moment. Question is, can you give some examples where CQPs of established mines have moved away from traditional techniques like AAS to more automated and simultaneous techniques? Simon, you're welcome to take this one as well. What was the process, and was the cross-comparison approach enough? Thank you, Michael. Simon or Tim, would you like to take that?
I think Tim can take that one.
Yeah, thanks, Michael. Yeah, sure. Look, we've had a number of companies use PhotonAssay. I guess one notable example would be Goldfields. Just to give a little bit of history to that, they did a number of studies, as Simon was indicating in the presentation, comparing PhotonAssay with FireAssay. And then they eventually transitioned to using PhotonAssay not just for grade control programs, but also for mineral resource and reserve estimation and so forth. So there's been a number of companies that have traversed that pathway. Simon, if you wish to add something to that.
You know, I can perhaps speak to personal experience. I first got involved with PhotonAssay. I'm trying to think when it was now. Maybe was it 2020-ish? With Novo Resources Corp, who were about to start off the Beatons Creek project, which is one of the papers that we've got there. They don't have the project anymore. But I mean, we went through all that. We went from a resource development database, which was a mixture of any assay method you cared to imagine. So leach well, screen, fire assay, and fire assay. I think there was some PALs and aqua regs thrown in there. So it was a database of many things. And we had to make the call as to how do we move forward, and what was the best option. And we ultimately went with PhotonAssay based on relatively limited test work. I have to say, I felt fairly confident at the time that it was going to give us what we wanted, given it was a coarse gold deposit that needed big assay size charges, and that I, as the qualified person in that case, had the confidence to move forward with it, and ultimately to sign off on a mineral resource estimate that was based on, well, eventually sort of 95% PhotonAssay. So it was a journey of discovery, and we did this. We did some science along the route, and spend a lot of time optimizing our sample protocols. Ultimately, we had a preparation laboratory on site that was independently run, and then the jarred samples were then shipped to Perth for the actual PhotonAssay analysis.
Another question from Matthew Brown. How does one define clean material? Simon, would you like to take that?
I think Jason or Tim can answer that one.
Yeah, I'll answer that one, Robin. Okay, so when we talk about clean material, it's in relation to the so-called interfering elements for PhotonAssay, and they are specifically uranium, thorium, and barium. It does go to one of the earlier questions around the detection limit. So as Jason said, on clean materials, in other words, with 0 or very low concentrations of those three elements, our detection limit is 0.01 ppm or 10 parts per billion. As the concentration of those interfering elements starts to increase in a way that we can model very accurately, then the detection limit does start to increase. But that is something that we can establish through modeling and also through empirical test work.
A question from Richard Tully. Thank you for the presentation. PhotonAssay is non-destructive. The CRMs, therefore, are not consumed, though PhotonAssay jars have a limited life. In your opinion, what's the best practice for rotating and changing CRMs under PhotonAssay?
I'll let Tim answer that one, because I think that's something that is Chrysos provides specific recommendations to clients on that one.
Yeah, thanks, Richard. Look, once a given CRM is properly jarred in one of our, I'll just hold one up here, one of our PhotonAssay jars, and has been carefully packed and prepared, the criteria is actually monitor how many cycles of measurement that particular jar has been through. And so basically after around about 65 measurements as a CRM, as a monitoring standard, which we log in the system software, we then rotate that jar out of circulation. The actual material itself is then preserved and then can be repacked into a fresh jar. So 65 measurements as a monitoring standard, and then it's swapped over.
A question from Alex Nicol. Outside of failure of CRM blank samples, is there anything on a standard assay report that should trigger a reassay, perhaps a het flag or a fill factor, etc.? Getting into the nitty-gritty here. Thank you, Alex.
Sorry, just say that question again.
Outside of a failure of the CRM blank samples, is there anything on a standard assay report that should trigger a reassay, het or fill factor, etc.?
Again, Tim, I think you can do that one.
Okay, good question. I'll answer it slightly in more general terms to begin with. So look, the system itself is running automated QAQC software. So on any given batch of material that we're measuring, we're already monitoring a number of aspects when we're looking at the performance of the monitoring standards that will be inserted in that batch. So if all is well, then the batch, when I say all is well, if they pass all of our normal criteria, plus or minus 2 standard deviation, 3 standard deviation, variation, etc., then the batch is released. If there has been a failure of one or more of those rules, those QC rules, then that batch is then reported to our physics operation teams, which are working around the world or across all of the major time zones. And then we'll investigate the reason for that and then subsequently release that batch. It doesn't, in very rare occasions, does it require the remeasurement, the physical remeasurement of one or more samples from within that batch.
And a great question here from Jared Taylor. I'd love to hear both Simon and Tim speak to this one. What do mine sites and laboratories need to consider when transitioning from traditional assay to PhotonAssay? What are some common factors and barriers that people may not consider before taking the leap?
I'm a proponent of very solid rig to assay optimization. So if you're sitting using method X at the moment and you're thinking of moving to PhotonAssay, then you need to get back to basics. You need to look at your drilling, sampling, assaying protocol very carefully, right the way from the face to the assay or the rig to the assay, whether it be RC or whatever. Have you done your heterogeneity studies? Do you really understand your ore type? Do you understand your gold particle sizing? What's the relationship between gold particle sizing and grade? And then you need to do your detailed analysis as to work out what the best protocol is going to be. So for instance, something I looked at recently, moving from fire assay to PhotonAssay, the big problem there was actually using crushed material and splitting crushed material because of the heterogeneity at that stage. Therefore, the conclusion was the fact there was actually the need to pulverize and then PhotonAssay to actually reduce the fundamental sampling error at that stage. So you need to do your homework. You need to do your homework properly as well.
Yeah, that's a very good point, Simon. I guess, look, I'll add to that in the following way. As Chrysos, we help our potential clients or current clients do these sorts of studies, which the ones that Simon was alluding to, we call a heterogeneity study, where we start to classify the CV, the coefficient of variation, whether it be PhotonAssay on crushed material or PhotonAssay on pulverized material, which can then be compared against the existing technique. We find in some cases that, there is sometimes a starting notion that their existing fire assay result, if we assuming the existing technique is fire assay, is in a sense perfect. And then so our result has to be absolutely 100% consistent with that. But as Simon is suggesting, it's a good opportunity to go back and reflect on the total chain of activity from the collection of that primary sample and all the way down through both mass and particle size reduction until the actual assaying technique itself. With our empirical studies, we can help clients define what they'll be getting from PhotonAssay, and then the client has got the information to make an informed choice as to what they need for that particular purpose, whether that's grade control or resource or exploration, or indeed in the metallurgical processing plant.
Thank you again for spending part of your Thursday with us. I wish you all a pleasant afternoon, evening, morning, wherever you are. Thank you.